Hello, everyone. I'm Seven and I will share what we built and what we learned from when we built a cloud communication platform with FreeSWITCH, NATS, and connect to SignalWire. First, about me, I know a lot of people already know me, but I have a new friend here. So a little about me. My name is Seven here, and I'm from China. I started using FreeSWITCH since 2007, and my first FreeSWITCH patch at 2009, and I'm the top 5 contributor according to GitHub. I wrote some video codecs, video conference covering core and a lot of models. I have attended 10 more ClueCon I can. Mostly as a speaker, starting from 2011. And I won a lot of dangerous demos, fire. I authored a FreeSWITCH Chinese book in 2014. And also I wrote Kamailio Chinese book at the last few years. And I also co-authored a FFmpeg book. And 2023. I founded my company Yantai Technology in 2016 in China. And also I'm the founder of WebLinks, as you see in there. And this year in the United States, this is my books. So the early days, first I joined a startup. We do online training platform. We use VoIP, and the trainer in the United States, and we have students in China, and so we need a phone system to connect them together so they can talk to each other. We first using **, and later we replaced ** with FreeSWITCH. That's in 2008. Just a few days before 1.0 finished version. Is there anyone use that version? No? OK, that's pretty old. So during that day, I learned reporting and fixing bugs to FreeSWITCH. I really learned a lot from FreeSWITCH. I founded my own company later at Comm, and would do some FreeSWITCH training and consulting, and also help people building call center 2011. And that's also the first year I came to ClueCon. I founded FreeSWITCH at 2016 later, and we still do FreeSWITCH training. And from that, we started building a product called XSwitch. It's basically a PBX system. And I also did some contracted work with FreeSWITCH solution and SignalWire. I wrote the initial FreeSWITCH Twimo model is made by me in the SignalWire and SignalWire. We were working on XSwitch. XSwitch became all-in-one solutions, software switch platform and solution far beyond a PBX now. And XSwitch.sing also became a cloud platform. So let me talk a little about XSwitch. What is it? So it's basically in PBX. It has a web console, and it has built-in Lua script and a web server. Everything was built in. We do not use PHP. We do not use other web servers. Everything was built in. I extended Model Virtual for HTTP server, and we use Lua scripts just for Lua in Nginx and Lua in Kamailio. We use Lua in FreeSWITCH for both call routing and both for web server programming. Since modern web server, you do not need to write web pages, right? Web pages is Node.js. You can write that with JavaScript, but at the back end, you only need to describe JSON, right? To exchange with that. We built a lot of features and modules and powered call center, video conferencing, and we also do 4G and 5G and IMS, not IMG, interop in China, mobile, and so we can do video calls on your phone. And we built a cluster in the cloud, powered and powerful easy APIs and RESTful and NATS-based WebSockets. I will talk about NATS later. We focus on on-prem installation, and even on the cloud, we can help people to build on-prem cloud. We made BFCP for video conference, and important. So BFCP is important to interop with legacy video devices, and we can also integrate with Angora. We can talk to Angora. So Angora guy had come also today. Angora is a cloud WebRTC solution. They're doing pretty good work, but they do not do SIP yet. And we built a gateway so we can do SIP to RTC and RTC to SIP. And also Angora, it's a SFU for conferencing. And basically FreeSWITCH is a MCU, so we built a gateway to do MCU and SFU exchange. Also, we built a lot of ASR TTS models for AI agents and ChatGPT also. So I want to mention a little about BFCP, highlight a little. So BFCP, it's a business flow control protocol. It's SIP. It's a SIP for screen sharing. So when I talk about here, there's the camera for me, and another one, it's the presentation, right? So a SIP device need to do it called to the video stream. So basically, when a SIP device, that was Polly, send an invite to join a conference, it's not like normal SIP code. It has two video streams, so two video media streams. And what we did is that we split that into two different SDPs. When it hits FreeSWITCH, we split that in mode Sophia. So because if you look at the FreeSWITCH code, the FreeSWITCH core media is very complicated. It has 10,000 of code. It's very hard to hack. And we hijack that SDP in mode Sophia. We split that into two different SDPs. And the first SDP we sent to mode Sophia, the FreeSWITCH core as the normal core, and we built a fake SIP channel. Then there are the two channels alongside with the main channel. So there are two channels in FreeSWITCH, and we can send both channels to the conference. We do not need to modify anything of the conference model, so two different channels can join the same conference. And also, since there are two different streams, we can send the different stream to Angora, whatever, so we can make that work. And talking about Angora, it's really complicated. I do not want to explain that in detail, but you just need to know it's very complicated. We bridge MCU and SFU. So basically, SIP from the left side, when SIP device join an X switch, we send each stream into Angora SFU. And when it comes back from the Angora SFU, which is WebRTC or RTC, all the streams come to FreeSWITCH, and we needed to put all the different video streams into an MCU, and we merge them together since SIP devices only support one or up to two video streams. We merge that together into one big stream, and we send back to each SIP device. Basically, it's that. Another thing I want to highlight is that AI. Everyone today doing AI, right? Actually, AI is not a new thing. The technology is pretty old, and the theory and technology is actually pretty old. I'll show you. Oh, sorry, I have no audio here. It's
David Mason of Cambridge Adaptive Communications. On the computer, I run a program called Equalizer. A cursor moves across the upper part of the screen. I can stop it by pressing a switch in my hand.
That's Stephen Hawking. It's pretty 30 or 40 years old, right? It's pretty good. Actually, it works, right? So it's pretty old technology. But why AI become true for recent few years? Because they're OpenAI, right? OpenAI made that with ChatGPT, and so GPT means a generative pre-trained transformer. So that transformer technology is actually built like 50 years ago, but it became true because there are two reasons. First is big data. Now we have a lot of data. We can train the model very efficiently. And another is the hardware, right? NVIDIA made very good GPU that can efficiently transform all the data. So it made that happen so everyone can use that. But ChatGPT only doing chat. It is text, chat, and text-based. And doing FreeSWITCH, we need audio and video, so we need the ASR and TTS. And actually, for TTS and ASR, there is a standard protocol called MRCP. It's basically Media Resource Control Protocol. And it had two versions. Version 1 is the RTSP-based. Another one is SIP. So the version 2 is SIP-based. It's also using SIP. It's using SDP and RTP, and everyone familiar with that. But it's a different protocol. And there's the open source called UniMRCP, open source project. And FreeSWITCH also has a UniMRCP model called mod UniMRCP. But FreeSWITCH moved that model out of the main tree a few years ago, since not many people using that, and it's a dying protocol since every new AI, ASR, TTS vendor changing to a new protocol, they're using WebSocket. Since MRCP is very old, it's not designed for modern, internet, right? And eventually, we have to write a model, one model per vendor. In China, we use Alibaba, Tencent, Baidu, Huawei, Minimax, and we also use Azure in China. So we build we build a model for each vendor, so we can talk to their ASR and TTS. We also build our own WebSocket-based WebSocket stream to our own protocol to implement some local ASR TTS model. We built mod AI with local Whisper and VOSK. So it doesn't scale well, but sometimes some people need only one or two ASR or TTS concurrently. We do not need to build a whole large language model, build a bunch of servers. So we made that in the model inside the FreeSWITCH. So everything in one FreeSWITCH, and it works, right? For only a few channels. Okay. And now everyone knows that ChatGPT using SSE. It's pretty HTTP protocol for long connection. It's pretty new, but ChatGPT using that, it's called server sent event. So when you go to a web server, it will keep sending events. So the event is very it's text-based. It's very actually it's very simple. This is the comment, and when it sends a message, like it can send an event ID and with data hi, and also the event ID is actually optional. For example, it can send hello, how do you do? Everyone using ChatGPT now that generative AI is very slow, so it will progressively give you the letter or the tokens, right? And the SSE is behind that, the protocol behind that. And you can also send each word separately in different messages. So basically, that's SSE behind ChatGPT. And at the LUT, it will send a DOM, a special DOM, tell you that all the whole message is finished. And we built that into Modular and curl. Since curl is an HTTP client, I already know that, right? So we extend that to support SSE inside the FreeSWITCH. And we also made modified some Modular. If you know that FreeSWITCH, if you use the FreeSWITCH with Lua and the ASR, you know that FreeSWITCH has an input callback. And so when you ASR detected some speech, it will call the input callback. And then as you know that ASR detects speech. And we extended that when, so when you detect the speech, you will send to ChatGPT, right? And then when ChatGPT gets back, you will get another callback called ChatGPT SSE. It's called Lua curl, and you can progress that, feed that all this stuff into the TTS. So, but you cannot wait it down because it's so slow. You need to. So we cut the sentences with punctuation. So we send to TTS progressively, so you can look like it's real time. And it also works, but. It's limited, and it's kind of limited, and it's lightweight, but kind of limited in Lua, since you cannot do a lot of things. So we can also control that externally. This is an example that with the Go language, and we made that a segment to split sentences. So you just see the separator below that, that you can define a lot of punctuation. There are the Chinese and English punctuation. We put that. We can split a sentence with that. Then you can send to TTS. So it can be real time. OK, to control FreeSWITCH externally, we do not use in ESL. Since ESL is plain old, and it's a little hard to control. And we made that with NATS. So what NATS? So basically, NATS is a message queue. It's write in Go and a cloud-native implementation. And like any other message queue, you already familiar, maybe RabbitMQ and Kafka, right? So it can do pub sub. You can subscribe to a topic. It's called subject. And the publisher, you can publish messages, you can get it. And another feature is that it's queue group. So the subscribers can join into a queue, and the messages put the subject into the queue can be delivered in the Robin manner that it can do distribute different messages to different subscribers, like a load balancer. So OK, every message queue can do that, but NATS has really a great feature called NATS, called request reply, and so the publisher, when the publisher publish a subject to the subscriber, and it will put a one-time mailbox, a string, along with that. So when a subscriber gets the message, it will publish a message to the mailbox, and the publisher, only the publisher, not the mailbox, and it subscribes the mailbox, so it can get the message back. So that's how it do request reply. So it's perfect for RPC. You can send a call to the server and the call wait for a reply. We're using that to control FreeSWITCH. Here is an AI example that you can write your own controller in any language, since NAS has a lot of language support, C, Java, Go, C#, anything you need. You can write a controller, Node.js, whatever. So when a call comes into FreeSWITCH, FreeSWITCH will generate a we wrote a model in FreeSWITCH. It will send an event, publish an event to NAS. Let the controller know that a call is coming, and the controller can send a command to FreeSWITCH to answer, playback, detect speech, or whatever. So it can control FreeSWITCH with message. The good thing is that with NAS, if a FreeSWITCH goes down, the controller doesn't need to reconnect to FreeSWITCH, since it's just need to connect to NAS, to the message queue. And all the media, audio and video, do not exceeding a FreeSWITCH. They directly send to ASR and TTS server. So you can your controller is very lightweight. You can just control a FreeSWITCH using controlling messages. And but sometimes the people want media. They want to process media by themselves. So we also made both way media or WebSocket. We can send all the media to a WebSocket server, and people can build their own WebSocket server, and they can connect to their own LLM and ASR, TTS, whatever. We also have that model. You can control that. The call sending out media via WebSocket. It's both way, so it's like dialing into a WebSocket endpoint. The at-risk guy just talked, right? Okay. Talk about real-time that actually OpenAI made everything simpler. They have a real-time API, and you can just send streams with WebSocket to OpenAI and forget about ASR TTS, since everything is built in their real-time multi-mode language model. But we also write a model, an experimental model, connect to OpenAI real-time, but it's kind of limited because first it's expensive. Another is it has hallucination. Like when I talk to it, sometimes it generates audio and text, but sometimes audio and text doesn't match. I don't know if everyone tried that. And also I talk that with English or Chinese. Sometimes it responds with German or Korean or sometimes. So it has a lot of problems still. And well, it's hard to embed your own stuff. RAG, no. So we don't use that. We only experiment that. Okay. Let's go on talk about the FreeSWITCH cluster, the secret of scale. So since everyone wants to scale endlessly, right? The way we built NATS into that is to help FreeSWITCH scale endlessly. So we use Kamailio for SIP, right? When you call command to Kamailio, it will hit Kamailio and load balance to different FreeSWITCH servers. One FreeSWITCH server will pick up the call and generate an event to NATS. And the NAT will send to one controller in a load balance manner. And once the controller gets that message, it will send a message back. So the FreeSWITCH server and the controller will connected virtually for this call. So one controller will control one call and one FreeSWITCH. And we can scale that endlessly. So for example, if you want to add a new FreeSWITCH server, you just add it, right? It will pick up by everything. It will just work. And if one FreeSWITCH server goes down, and we have Kamailio and the controller listen to events and listen to heartbeat, and it's not a FreeSWITCH server goes down, and it will remove that from the list, and everything goes scale up and down endlessly. So we do not even only talk about scale up. We also scale down with we built FreeSWITCH with OpenWRT with small device. We built that in hardware. We also built FreeSWITCH with OpenWRT on Docker. It's an AP. A manufacturer in China made that AP. They have OpenWRT, and in that they have Docker. So we installed XSwitch into that. It worked, right? So we have different architecture now. We have everything. Let's back into our cloud. Okay. So in the cloud, we need to support multi-tenant. So we made that per tenant, per FreeSWITCH, per Docker. And we use one big database. We use PostgreSQL, but different schema. PostgreSQL actually very good. So split different tenant into different schemas. We can connect. We also use Kamailio for zip and FreeSWITCH different Docker. This is a Kamailio script. We use a simple map to map domain into our Docker IP, and we send a message to FreeSWITCH. And finally, WebLinks. We are trying. We build everything in China, and we're trying to bring everyone to everything to duplicate everything that is good to WebLinks in here, and we link phones, WebRTC, and AI connect to SignalWire on-premise deployment available. I'm talking about PostgreSQL. Actually, PostgreSQL is very powerful. We modified the Lua. We use dbh.query. We modified the core to support the numbers and board. Since in FreeSWITCH, it only supports text. We modified that. We also use PostgRET. Basically, PostgRET is an open source project. It can turn a FreeSWITCH server, a PostgreSQL server, into a RESTful API. You do not need to write the code. You just we learned that from Superbase, and you just need to define row-level security, and everything will work with a RESTful API. Okay, finally, SignalWire. We also connect to SignalWire. We use SignalWire for phone numbers and zip chunks. We use one project of one space per customer, depending on the customer, right? We also use SignalWire billing. That for some customer, because customers do not use on-premise billing, we do not know how many calls. We have no billing. We just took up all the SignalWire billing and multiply 2 or 1.5 or 2.5 and charge the customer. We use SignalWire API and XML, SWIMO, and real-time SDK. We started Python, Go, and finally we chose Node.js because Node.js is more complete than the Python and the Go one. It's very simple. When you hit SignalWire, we just use a Node.js and connect it to another PSTN call. We use that with zip chunks. So in summary, so FreeSWITCH and WebLinks, whatever you use, FreeSWITCH is a good media server and a good framework. It's well designed. Don't hesitate to write models. It's very easy and powerful. We wrote dozens of FreeSWITCH models. We write call flows and business logic in Lua, or controlling externally for external ones. We can endlessly scale with existing software, Kamailio, NATS, Postgre. We build our own. You can build your own SIP platform, call center, voice agent, whatever, with FreeSWITCH or WebLinks. Okay, that's it. Thanks.
Thank you, Seven, very much. Now, bearing in mind that Seven's made massive contributions to the FreeSWITCH project over the years, has anybody got any questions they might like to ask Seven while he's here? Stony silence, Seven.
Okay.
So you're free to go. Thank you again. Oh, sorry, there is one over there, Seven.
Okay.
Let me just run the mic to that man. Well, when I say run...
Sorry, I should come to you, Seven. Thank you very much. Did you mention NATS and RabbitMQ and the whole MQ architecture in your previous presentations? That's new to me from you, isn't it?
Yeah, NATS.
That's new.
Oh, yeah. Kamailio World last year, 2022 maybe.
So you've been using it for a while, and you
Yeah.
Okay.
Yeah, I talked on Kamailio World.
Okay. So no, I got to research that because I don't have a use case for it, but maybe it'd be a benefit to me if I learned more about it. Thank you.
Okay. Both FreeSWITCH and no. Kamailio has an open source NAS model, and we made one in FreeSWITCH. Not open source yet, but yeah.
Okay, thank you.
Okay.
Any other questions for Seven?
Okay, thank you.
Big thank you to Seven. Thank you very much.